All right, solving quadratics by taking square roots, and then on the back side we're going to do graphing vertex form. So let's just kind of jump right into this. So when you're solving quadratics, the two main ways that we're going to cover in class are we're going to have to factor and use the zero product property. I know Mr. Porter heard him call it ZPP, so I'll roll with that. This lesson, though, we don't really have to do any factoring. We don't have to use the zero product property, because if you notice, all of these expressions here, they have an x squared in there, but there's no x term. So that's kind of a tip-off that, hey, I might have another way of solving this. And so everything we're going to do today is going to be done with taking square roots. So let's get after it. I'll do number 1 and 2, then I'll let you do the rest. So number 1, the idea is I want to isolate this x squared chunk, that whole term. So I'm going to get it by itself. So I'm going to add 5 to both sides. And I'm going to get 2x squared equals 18. And then my next goal is to get x squared by itself. So I'm going to divide by 2. So right now it's pretty much just like normal algebra. And then down here at the bottom, to get rid of that squared, the opposite of squaring something is to take the square root. So the second that I do this, that and the 2 cancel each other out, and I'm just left with x. But if I take the square root of the left side, I got to take the square root of the right side. Here's the part you really got to be careful on. The square root of 9, most people will just say, oh, it's 3. But it's actually positive and negative 3. So you get 2 solutions. Because these are quadratics, quadratics have 2 solutions. Both of these answers, x equals positive 3 and x equals negative 3, are both going to make that equation up above true. So don't forget your plus and your minus on your square roots. I'll do one more just to make sure you got it. So here I'm going to do the opposite of plus 4. I'm going to minus 4 from both sides. I got 3x squared equals 432. And divide both sides by 3. Boom, boom. And I get x squared equals, thank you, x squared equals, what's that, 143? I think it's 144. And when I take the square root of both sides of that, it's positive or negative 12. So, pretty similar to regular algebra with that little twist at the end with the square roots. So I'm going to let you knock out number 3. And we're going to come down, and I'm going to do number 4 with you. So I would say half the kids on the SAT, if they were given this question, the very first thing they would do, they would try to expand this. Now don't write this down because this is wrong. But they would probably say, well, I'm going to do x minus 10 times itself. And they would expand it to get this, because that's what we've been working on in Khan Academy. However, you just went backwards. Like, you made it even harder to solve. So what you want to do, instead of going down that road, which kind of seems normal, is I want to get this entire thing here by itself first. I want to get all of that alone. So I'm going to start off the same. I'm going to add this 1 to both sides. And I'm going to have parentheses, x minus 10 squared equals 1. Because I can still get rid of that squared symbol by taking the square root. It's just, I'm going to square root this whole thing right now. Boom. And immediately, it cancels with that 2. And then I'm just left with x minus 10. Now, if I do it to the left side, I got to do it to the right side. Don't forget your positive or your negative 1. And then here's where it differs a little bit from the top. I now have an expression. I have x minus 10 that I need to figure out, well, when is that going to equal positive 1? And I got to figure out, when is x minus 10 going to equal the negative 1? So here's how you get your 2 solutions. You kind of set up 2 cases. One for the positive case, one for the negative case. If you add 10 to both sides, you're going to get 11. If you add 10 to both sides, you're going to get 9. And if you were to try this, if you're like, well, I'm not sure if I did it right, all you got to do is go back up and plug it in and see if it works. So let's try this 11. If I stick 11 in there, 11 minus 10 is 1. 1 squared, take away 1. Well, that's 0. That checked out. So I know 11 works. Well, now if we try 9, and I try this 9 in there, if I do 9 take away 10, I get a -1. But when I multiply -1 times itself, -1 times -1, it turns out to be +1, take away 1. Well, that also works. So that's why there's two answers that can both work with quadratics, because you have that whole issue of there are two numbers that can times themselves to make the same number. I'm going to leave 5 and 6 there for you to do. Jump down to the next section. 7, 8, 9, and 10. So 7 and 8, it says find the zeros of the function. Same exact thing as what we were doing up above, except for the wording said find the solution. Sometimes on the SAT, they say find the zeros. Zeros are the same thing as solutions. And function just means they're going to use this weird notation to let you know it's a function. So to find the zero, you set it up equal to 0. And then you just get after it, just like we did up above. So I guess I'll finish it. I'm already this way into it. So I want to get the -5x squared by itself. So I'm going to subtract $1.80 from both sides. Boom. Slide that dude down. And to get x squared all alone, I need to divide. Some kids add here. Be careful. You don't want to add. You want to divide by that -5. Divide by the -5. And what we got? 5 goes in 18 3 times. 3 so 16 positive, because a negative divided by a negative is a positive. And we got a nice little perfect square, so that when I take the square root, I get x. And when I take the square root, remember I get two answers. Positive, -4. All right, 9 and 10 I'm going to leave alone for you, because these are exactly like numbers 4 through 6 up above, with the exception of you got to put your own 0 in for the function, but then solve it the same way. Now, I think the toughest part is the backside. Graphing quadratics in vertex form. This is a little funky. You're not going to master it in one day, like most things in life. So be patient. Just keep chipping away at it, Shawshank style. So vertex form, in general, the general form for vertexes is y equals some number, parentheses, x minus h squared plus k. I know that's a lot of letters. The letters that are always going to be there, there's always going to be a y in there, and there's always going to be an x in there. You're always going to have this squared. Now, everything else could change. The a, the h, the k, the a, they'll all change depending on the problem. Now, why it's called vertex form is because you can just look at a problem and you will know where the vertex is. And the vertex is always going to occur at the point hk. Remember, kind of an xy coordinate on the grid. So let me kind of go off the grid and just explain a couple things, clear up some stuff. So let's kind of make up something here. If you got a normal graph, I'm just kind of doing dirty, quick little sketches, so bear with me. But if we start off with the parent function, y equals x squared. Well, that's a parabola. It's a bowl that comes down, just kisses right there at 0 and goes back up. All right? And that spot where that bottom, that minimum is, that's called the vertex. Another thing to know is that all parabolas are symmetrical, meaning that there's a fold line right down the middle that you could fold it and it'll land on top of itself. Well, if you want to start moving this thing around and you want to start changing its position, and let's say that I want to move it, say I want to move it down 3 units. I want this thing to move down here, and I want it to have a vertex at that point. So I just want it to kind of move down a little bit. All I need to do to my equation is I just put a -3 at the back, and I just made it move down 3. Now, if I wanted to make it move up, like let's say I wanted to make it move up 4, I want it to be floating up here somewhere, all I would do is I just call that y equals x squared, and I just put a +4 at the back. So your back number is kind of your up and down controls. So when we go back to the original, that long funky one I drew on the other page. This K back here, this is what controls up for positive and down for negative. So that number's your up and down mover. Now your left and right is a little bit kind of weird. So let's say we start with our generic y equals x squared. You know, just our plain old function. Let's say I want to slide him to the right. All right, so let's say I want to move him over 5 spaces. And I want him to just kind of shift left a little bit. I want him to do that. Or shift right. If I want it to go that way, and I want to move this thing right, how I adjust the equation, how I tweak it, is the number inside the parentheses here. All right, so this is our right and left controls. So I wanted to move it right 5 spaces. So if I was going to do that, here's what I would do. I didn't move it up and down, so I'm not going to put a number at the back. But if I want to move it 5 to the right, and this is kind of opposite of what you would think, -5 actually moves it to the right. All right? So if it's minus a number, it's going to go to the right. Now that's opposite the way my brain thinks it should be, but when you actually do the numbers, it just doesn't work out that way. Let's say I wanted to shift it left. Let's say 3 units. Say I wanted this thing to come down, and I wanted to move it to the left 3. Well, that equation is going to be y equals x. And if I want to go left, I actually put a +3 in there. So this moves it left 3, and this one over here would move it right 5. So inside the parentheses is left and right. It's kind of backwards, but right is the negative, and plus is the left is the positive. Now, we don't really need to learn a whole lot about A right now, but A kind of does its own thing. I know Mr. Porter's already hit this once this year. For some of you guys, hopefully it's review. But your number in front is either going to stretch it or it's going to shrink it. And it's also going to tell you whether it opens up or down. If the number in front is positive, you're going to open up. If the number in front is negative, you're going to open down. I threw a lot at you, man. That's a lot to keep track of. But like I say, you're not going to get it all in a day. So let's put it all together really quick. Let's just kind of say, let's say that I give you something like this. Y equals x minus 7 squared plus 4. All right. Well, what this thing's going to do, just looking at these numbers, I like to start at the back because it's kind of easier. Since it's positive, I know this thing's going to move up 4 units. So remember, everything starts from 0, 0. So we're going to go up 4 units. And then since this is minus, it's backwards from what I think it's going to be. It's actually going to go right 7. So let's kind of plot that out. If we go up 4 and then right 7, that means my vertex is right here. All right? My vertex is right there at 7, 4. So that's the bottom of the bowl. And there's no number in front, so we can just pretend it's a positive 1. So this thing is going to look something like that. Now, if I were to just throw a negative in there just because I feel like it, it's going to look like that. It's going to flip it, make it go upside down. All right, I think that's a little bit of enough background to maybe get in and get our hands dirty with a couple examples. So let's just kind of see what shakes out. I don't know, maybe we'll do number 12 over here. So looking at number 12, I see that this thing went down 2, and I see that it went left 3. So that gives me a really nice vertex to kind of think about. So left 3, down 2 means that's where my vertex is going to start off at. So it's going to be right down here. And I kind of know because I'm peeking. You know, I'm kind of, my eyeballs saying, hey, I'm going to peek right here. that front number is positive. So I kind of know that this thing is going to go up, because I was thinking about sliding my screen up because I thought I might be going down there. But when I peeked at that front number, I'm like, I ain't got to worry about it. I'm about to go up. So thinking about your chart, so far we got 1 point. I'm going to slide it down here. We got 1 point locked in. I want you to have 3 because 1 point's not going to be good enough. So I want you to get 2 other points. So it's your call. You know, I've done the x equals -3. Maybe I'll skip a couple spaces away. Let's try x equals -1. Let's throw that in the mix. And I'm going to show you what's kind of cool about if you get 1 point, because remember how parabolas work. Parabolas work that they are symmetrical. So what's cool is if I get 1 point on one side, it automatically gives me a freebie over on the other side. So let's see if I can get a freebie here. So I'm going to throw -1 in for x. Let's go back to this equation and let's rewrite it with a -1 in for x. So I'm going to rewrite this guy. So y is 2 and we're sticking -1 in there. So I'm plugging this dude in to see what happens to y. And you got to do a little math. There's no way around that. So parentheses first. -1 plus 3 is 2. So order of operations say do parentheses first. They then say I got to do my powers. 2 squared is 4. And now I think I can finish it. 2 times 4 is 8. And 8 take away 2 is 6. So y is 6 when x is -1. So -1, 6, bam. Well, what's cool is because we have a symmetry line or a fold line, I know that that point lives on there too because it's symmetrical. And now you can sketch yourself a nice little parabola in your money. You're good to go. So, step 1, get your vertex. Step 2, pick another x on one side or the other, and it should give you a freebie. And what I mean by that freebie is, since I locked in -1, that also told me what -5 was. Because this vertex is in the middle. So it kind of repeats itself on both sides like that. Now you're going to screw it up and you're going to mess it up, and that's totally fine. I want to see you try the problems and mess it up, and then we can come back and work through it. But the worst thing you can do is limp back in with nothing done. Then we don't really have anything to start with. See you.